All right, can you see me or my screen?
Yes.
Yes.
All right. So in this section, we'll discuss how MATLAB interacts with Slurm. There's a Slurm scheduler inside of MATLAB that you can use to start batch jobs from within MATLAB, within the GUI. And so we'll walk you through how to set those parameters and then how to run the jobs. So MATLAB is pretty well integrated with Slurm, and because of that, you have a couple of different options to run these jobs. You can write a script like for any other software and submit the job with sbatch using or at the regular command line, like a bash or a tssh. You've seen this in the previous section. However, one of the more popular and easier ways to do it is to use the job scheduler built into the MATLAB GUI. This is the batch command. The command is just called batch. And then alternatively, if you're actively working on development, you might want to use a par pool that keeps the parallel session open while you're working on it. And you can use that with a predefined cluster with predefined settings that can be preserved between different sessions or saved to a profile that you can restore from different sessions. In the following sections, we'll extend these last two options. This is what we'll be discussing today. Here's a reminder for the compute allocations and the storage space. On Cosmos, you've got plenty of space, but in everything else, you have a project directory. Just as a warning before we go any further, longer resource-intensive or parallel jobs, any longer resource-intensive or parallel jobs must be run through a batch script. That can be, you can use batch in the GUI or you can use batch in the Slurm command, but it has to go through a batch script. Or has to go through some kind of batch command. On login nodes, if you're going to start MATLAB on a login node, you have to use the single comp thread. And you can submit Slurm jobs while in this type of session, but it's not really recommended unless it's the only option available. And on the clusters where it is possible to use like an on-demand app, like on Cosmos or Kebnekaise, it is possible and therefore recommended to start the MATLAB GUI itself on a compute node. So in the previous session, the MATLAB desktop or graphical interface was introduced via various mechanisms, whether you get to it via the interactive command or via on-demand desktop or open on-demand. This is more or less what it looks like. To submit a job from the GUI, you have to create a handle for the cluster and then use this handle to submit to send the job and control the outputs. So for instance, you typically define C equals par cluster, and you give it the name of this cluster profile that you've hopefully already defined, and we'll talk about how we do that in a second. And then you run the job on the CPU by calling the batch attribute off of this variable that par cluster was assigned to. So you can say like J or job equals C.batch. Then you give a little @ symbol with the name of your function, the names of the output values, or the name of the variable to assign the output. The number of values of output values you expect, and then the list of inputs, and then you can specify like pool and then number of workers. There's a typo in here. That should not be there. And you can also instead of calling batch as an attribute, you can also use batch as a function and pass the par cluster or the cluster handle as the first argument, and then the function is the second argument, and everything else is the same. And as long as the job is running, you can call job.state and to see where you are in the process. You can also use and then you can later on just fetch the outputs with job.fetch outputs and then curly braces and colon. Note that batch also accepts the script names in place of function names, but these must be given in single quotes with no @ and no .m. Those would be good for something like a job farm. And here I will show you how to set the job settings in the cluster profile manager. So this is something that you can do. You can do this on the command line, as you may have seen already in the interactive session, where you set some parameters with the cluster config function, or with additional properties. This is how you do this in. This is how you're going to do this in a GUI. So I'm going to very quickly start another MATLAB session on Cosmos, and I'm just going to give it 60 minutes just in case. And I'll leave the account numbers alone, all the features alone, everything else is fine. Just going to go ahead and hit start. And once this loads, then I'll be able to go under. Once this loads, I'll be able to go under the parallel. I'll be able to go under this parallel menu and then go to create and manage clusters. And that's where you'll find the options to alter your cluster profile parameters. Oops, wrong thing. So this is starting. It should load any second now, although this was slow, a little bit slow in the last session. Should have had this started already. I shouldn't have closed the one I had last session. All right, let me see if I can't find okay. So any of the parameters, basically what I'm going to be showing you is that any of the parameters that you might otherwise on the command line set with C, like let's say you've assigned a cluster par cluster to a handle C, and then you want to set properties like the wall time or the memory per CPU, the processes per node, things that you would normally set with the attribute additional properties. So you would do C.additional properties dot the name of the property set equal to a value, and then you would put and then you would end it all with C.save profile. This is the same thing, but you're setting it in a GUI instead. Eventually this will load and I'll be able to actually show you. This was not this slow yesterday. And it's incrementing awfully fast too. Well, it does say 60 minutes. I don't know why this is taking so long. This did just work like 15 minutes ago, so it will eventually start. Okay, this is ridiculous. I'm gonna stop this. And then I'm gonna change this to the 2023B instead. I don't know why it's taking so long today. This shouldn't be doing that. There, now it's starting. My apologies for the delay. This wasn't this bad just even 20 minutes ago. All right. I realize the text here is a bit small. It doesn't play well with my my desktop settings. No, I close that. Yes. So I'm going to close this and then open the parallel box here. So the way you set your the cluster, the job parameters for your cluster profile is you go here to you can either go to create and manage clusters or parallel preferences. They're kind of both. Either way, you want to go to you want to find this parallel computing toolbox preferences just here in this list, kind of far down, and then you click Cluster Profile Manager. And then you click Edit, and you scroll down to the Scheduler plugin. So here is where you can set the default values for your account. So the parameters for this this is LU 2025 7-37. Oh, that's different. That's different from what I selected before. Whoops. 7-37. So I'm going to replace these values 7-37. I'm going to leave the memory usage per core the same. I can submit an email address if I wanted to be emailed about my the status of my jobs. And I'm going to set the default wall time to 60 minutes, for instance. And procs per node, I'm going to reduce this to 32 just in case. Or no, actually, I'm going to reduce it to 16. And then I just click Done. Now all these settings are saved. Then and then when I start a par pool, it would have those settings. So if I do C equals par cluster 2023B. No, it's Cosmos 2023B. And now you can, and now I've gotten the handle to the cluster, and you can see that it's saved the like the preferred pool number of workers. That's that property was saved from the profile that I just had. And if I do C dot additional properties, dot wall time. See what that prints. Yes. And now you can see that it saved my the change of settings to 1 hour as well. I see comments in the chat. Okay, so those are not questions. All right, so I think at this point I've used up a little bit too much of your time, so I will turn it over to Pedro for the for the rest of this section. I will note one other thing. The settings in the scheduler plugin for any given cluster profile are saved between sessions, so you should always check what the values are before you actually run them.
So, okay, I can continue with the next section, which is more about the interaction of MATLAB and Slurm. We have seen that the extensive jobs must be run through Slurm, so you shouldn't run these jobs on the login node. And it is very important to realize on what node you're running. So we have seen that there are several manners to run a MATLAB or an HPC cluster, right? And it's important to note where you are sitting, yes, if it is a login node or if it is a computing node. So we have seen that we can run a MATLAB using the GUI, for instance, through ThinLink, which is supported at LUNARC, UPPMAX, HPC2N, and also partially at PDC. Yeah. And here in ThinLink, we can start the MATLAB GUI from a login node or from the interactive session, right? So some versions for this are the ESA log, as this one is supported at HPC2N and interactive is supported at UPMAX. And there are also some more graphical options that are supported in other clusters. For instance, at LUNARC, there is a support for a desktop on demand, right? And at HPC2N, we have an open on demand version, right? I will cover briefly this part if it is a time. And there is also a manner to run MATLAB, and this is through the common batch scripts. And this can be done, for instance, by submitting your job as a regular batch script with sbatch. And this is less recommended, but this can be useful if you are only interested in getting data, yes, data production from MATLAB, and you don't care so much about the graphical analysis that is supported in the MATLAB GUI. So here I will talk about a bit further on the syntax for the MATLAB functions, right? So here there is an example for running a serial job, yes? And in this particular case, I am writing here a serial function. Serial means that this function will run on a single core, right? So I can write a file, a call, for instance, host nm.m, and this is the extension supported by MATLAB. And in this function here, this file contains just a single function, right? Call with the same name, yes? And this will return just the name of the host, right? So how to interact with this learn with this particular function? So we can create a handler, as Rebecca mentioned previously. And here we pass the name of the cluster, and this will depend on the HPC cluster where you are running, yes, and also the type of the job that you are targeting. And after you get the handler for the cluster, then you can also get a handler for the job. And here, then you can post process the results and yes, and get the outputs. So this is a particular case for a serial function, right? And I will show you how to run this using one particular version, yes, of this protocol that I mentioned before, and this will be with ThinLink, and in particular with HPC2N. So assuming that you are connected already to a ThinLink session, and you open MATLAB, right, as Birgitte said before, right? I loaded first the MATLAB version, this one, 2023A, and update 4. And then I start MATLAB with a single com thread to avoid MATLAB using the entire resources for this login node. Notice that here I am in the login node because I connected through a thin link. And this is the part where you need to be aware that you are sitting on the login node, and then you shouldn't run the job, yes, with this button here, especially if this is very expensive, right? So what could we do in this case? I have the function that I mentioned before, yes, for getting the host name in serial mode. Then I write another file for submitting the job. And here in the part cluster, I specify the cluster, which in this case is Kebnekaise. And then I pass the function, yes, that is stored in the file with the same name here. And here I specify the number of cores that I will use because it's a single core function. Then I specify one, wait for the result, and after that, the result will be printed out. Yeah. So then if I run the code with this button, notice that here I am running the submit job, not the function file. Right? So if I run this code, yes, this code is not running on the login node, but instead, if you are curious about this, you can check with sq-me, and you will see that the job here is running. Is this one is running on a computing node. So I am not using the login node capabilities, but the computing node. And at the end, you can see that the output is printed out, and it is just the name of the node where the job was running. Yes, it was this one. And then it's okay to run the job in this way. Okay, this was for a serial job. Then there is also some functionality in MATLAB for running parallel jobs. And one of them is by using the par4 method, yes. So in this case, par4 is used to run loops, yes. And there are some conditions that the loops need to satisfy. For instance, the number of iteration need to be well defined. And here we have no control over the individual workers, and also there shouldn't be any data dependencies between the iterations, right? So the loop should be fixed in this manner, right? So even though there are some restrictions on the loops, par4 is very useful, especially for scientific code, because in general, the scientific codes require loops that satisfy these criteria here. How does it work? Here I show you an example for a par4 loop. So basically, this is a for loop in MATLAB, but instead of using the plain for loop, you use instead the par4, right? So, and this is the syntax, yes? Instead of for, you write a par4, and then a MATLAB will try to use the available number of workers, right? I will show you in a few minutes how it works with par4. So there is also another functionality in MATLAB, but it's called SPMD, Single Program Multiple Data. And in this case, you have more control over the workers. If you remember in par4, you don't have a control on the workers that execute the independent iterations. But in the case of SPMD, you have more control, and they can be controlled through the variable called lab index. This can help you to specify which worker, yes, can execute the specific task. So if you're familiar with OpenMP, you will realize that this is the protocol for parallelization that OpenMP uses, although this is not based on OpenMP. Yeah. The third function that I will mention is parfeval, and this is more useful if you are doing asynchronous calculations and you don't care so much about the simultaneous parallelization. For instance, imagine that you are executing a different task, right? That don't require to be executed at some particular time and also simultaneously. And then in this case, you can perform the task at different points, and only when you need the data, you can retrieve them and execute them. So this is called asynchronous, and this in contrast to the previous protocol that we mentioned here, par4, where everything is executed simultaneously in a loop. So this is for asynchronous parfeval, right? And I now will show you how to execute the parallel jobs. Yes, and here there is an example for doing this. So if you remember previously, we saw how to print out the name of a host. And here I have a parallel version of the function. In this case, it's called host MP, right? And it requires an integer n to run the par4 n times, right? Here I will call the function host mp, right? .m, and I will require also a handler for controlling the cluster profile. Yes. So I can copy this function and also this function, and then go through my thin link session. Yes. So I did it already. So I pasted the function, and also the file is called with the same name. Yes. And it accept the input value. I also have a handler for the cluster profile, and this will call the function doing 4 iterations, right? And because I am doing 4 iterations, and they are split into 4 different tasks, then in principle, the total time should be divided by 4, right? So then I can run safely this script, because this will not run on the login node, but instead it will run through the batch system, yes, by using this number of cores. Let's submit this, yes. And again, if you are curious, you will see that the job was submitted to the queue. After some time here, it appears, right? And it should be running. Let me see. And you see that the output is here. The name of the computing node is printed out 4 times, because it simply performs this task 4 times, right? Okay, so there is another functionality that allows you to do an even more interactive workflow with MATLAB. And this is especially useful if you are working on an on-demand session, for instance, the one that Rebecca mentioned at LUNARC. And there is also a version for open on demand on Kebnekaise. But notice that they are not the same, right? They are different. And our version is called uh, open on demand. So if you have an account at HPC2N, you can click on this option here above open on demand, and then you will go to a portal. You will write your credentials for Kebnekaise, and then you will see, yes, different options the for the sessions, right? You will get into some window like this one. And then if you click on the interactive apps, you can choose the MATLAB proxy, yes. And here you can choose the project for the course today, and the number of hours with a maximum of 12. And here you can choose any. It means that any CPU, and also you can choose GPUs if you click on any GPUs. But I choose for today CPUs only, right? And here I specify the number of cores. In this case, it's just 4, right? So then I can choose a path, and this is the path where I will be working. Yes, you can choose the one where your exercises are located. And finally, then you launch the session. And after some time, you will get some display like this one, right? Where you can connect to MATLAB. So then when you click on this button here, so you will see some message related to the license. And if it takes some time, so in my case, it works by closing the session, right? That was open and then relaunching it with this button here, right? So once you do this, then you can see this window in MATLAB, right? So notice that I am using a dark setting here, and that's why it's seen in dark mode, right? But otherwise, we'll see that in the usual manner in the white mode, right? So how does this way work in MATLAB with part pool? So I mentioned that this is very useful in an open on-demand session, right? And here, so what you do is that you start the part pool with this option and the name of the cluster, right? And the number of workers that you need. Yeah. But especially if you're in an open on demand session, so what you can do is that you can start the part pool, but the name of the cluster in this case is processes. Because if you have noticed this, so we are running the open on demand session already on a computing node. So we are not using the resources of the login node, but instead we are already working on the computing node. That's why I can use this pool, which is a default pool in the latest versions of MATLAB. Yeah. So then I use uh, uh, four task or four cores, right? And then I start the part pool and run the part pool with four tasks and print out the name of the host. So I can run this, right? And you see that the part pool has started. And it is running locally on the computing node. So you see that it printed out four times the name of the node. So I have here another case, yes, where I have two functions, right? One that is called a serial, a sleep serial, and one that is called a sleep parallel. Yeah. And this function sleep serial just execute a loop n times. In my case, it will be four times, and then it will sleep for 10 seconds. So if I run this four times, in total, it would take around 40 seconds, right? But now, instead of using this serial version, the only thing that I need to change is part 4 instead of 4. And then this will be split into n task, right? And it will pause 10 seconds. So if I use four tasks here, then it will run four times. But because I am parallelizing that with n workers or four workers in this case, it will take a 1/4. So let's run this again because I am already running on the computing node. I can go here and simply run the case. And I am using the processes part pool. So first it will run the serial case, which takes roughly 40 seconds, and this is the consuming part. Yeah. So you see that the serial case took about 40 seconds, and now it is starting the parallel pool locally on the computing node. Yeah. And you see that it took about, let me see.
Yes, we see the time.
Yeah, yes, it takes about 10 seconds, right? One fourth. Yeah. Notice that, yes, I use the processes because I am in an open on-demand session. I am already working on the computing node, right? But if I use a thin link, and here, yes, I am working on the logging node. So that's why here I have to change the park cluster name. And in this case, because I am sitting in the logging node, the job will be sent to the batch queue. That's it from my side, and this is what I had to say about the different commands and types to run the jobs with the MATLAB GUI. Is there any question on this?